Hi, welcome to Systems of Equation Word Problems. So we're going to take those those different methods of solving, and we're going to put them in word problems. So we're going to apply the knowledge that we have. So what we're going to do for each of these, we're going to write a systems of equations, write a system of equations to describe the situation below. We're going to solve using any method, and then we're going to fill in the blanks. So basically, we're going to answer the question down here. So with this, Mrs. Brady is shopping for school supplies with her children. Layla selected one 1-inch binder and one 2-inch binder, the total cost of $9. Isabel selected one 1-inch binder and three 2-inch binders, which cost a total of $23. How much does each size of binder cost? Now, in order to set this up, we need to find out what our variables are. You are typically going to get your variables from the question. How do you find a question? Look for the question mark. So the question is going to be what you are going to be answering. So that's where your variables are going to come from. So when you look at this and it says, okay, how much does each size binder cost? So we're going to break it down and we're going to look at the cost for a 1-inch binder, 1-inch binder. And the other one that we have is the cost for a 2-inch binder, 2-inch binder. So now we have X's are the number or the cost for a 1-inch binder and Y's are the cost for a 2-inch binder. So let's go back and look at this. Let's look at Layla first. Layla has one 1-inch binder and one 2-inch binder. So Layla has one X and one Y. So we can total up the cost of this by saying, okay, the cost for one X plus the cost for one Y is $9. So we know that that's going to equal 9. Isabel now has one 1-inch binder, so 1X plus three 2-inch binders. So Isabel in this case is going to have three Ys, and the total cost is going to come out to be $23. So now we have 1x plus 1y equals 9, and we have 1x plus 3y equals 23. Well, if you look at this, this is set up to solve by elimination. My x's, my y's, my equals, and my constants are all lined up. So solve by elimination, we have a 1 and a 1, perfect candidate to get rid of. We'll make the top one negative. So we'll multiply the top by a -1. And that's going to give us a -1x minus 1y equals -9. And the bottom we didn't touch, so we're just going to copy that down. 3y equals 23, and we can add right down the line. Our x's are going to cancel each other out. Our y's, we're going to be left with 2y equals 14. And then we can solve for y by dividing by 2. Now, once you solve for y, just like we did before, you can take that information and you can plug it back into the equation. So let's look at the first equation. So let's take that information and plug it into the first equation. I said 2. This should be 7. Sorry. 14 divided by 2 is 7. So we're going to plug that information into that equation there. So we have 1x plus 1 times 7 equals 9. And we know 1 times 7 to be 7, so we have an x, we have 1x, or just a single x. We don't really need to say 1x. 1x plus 7 equals 9. Subtract your 7 from both sides, and you get x equals 2. So now we know that my y is 7 and my x is 2. We take this information and we can go and we can put it back in the context of the problem. So a 1-inch binder is going to be an x, which is going to be $2. And a dollar for a 2-inch binder, we know that y is going to be 7. So we know that a 2-inch binder is going to be $7. So when it comes to answering the question here, we know that a 1-inch binder is going to be $2, and a 7-inch binder is going to be 7.